Hello, this is Jason McComb with Oregon Tech, and this is my senior capstone project. My senior capstone project brings together the main components of an electric drive system that can be implemented in an electric vehicle conversion. And my system is a DC system to include a DC motor, motor controller, and battery pack. And I chose to go with the DC system for its simplicity and overall cost when compared to an AC system. And I'm just going to demonstrate the functionality of everything working together. I'm going to give it a throttle input and vary the speed of the motor. A quick run through of the connections that I have here. To the left, I have 3 battery modules in parallel of 18650 lithium-ion batteries, giving a total of 46 volts to the power section of the controller here. I got a battery plus, battery minus, motor plus, motor minus, current sensor connected to an Arduino Uno, which puts out the current reading of the motor draw, which the motor is drawing on the LCD display. The controller here uses the speed control method of pulse width modulation, which takes in the throttle input and converts that to a pulse width modulation signal and feeds these gate resistors here, which go down to the gates of the power MOSFETs on the power section on the bottom of this controller here. I have 10 in parallel. On the other side of this controller on the bottom, the controller is split into 2 sections, a power section and a logic section here on top. The power section has 10 MOSFETs in parallel, as I said, 10 free wheel diodes on the other side of this heatsink, and 16 capacitors in parallel to smooth out the voltage ripple. And this controller is capable of handling 500 amps and 144 volts. The motor here is a 100 horsepower motor. It's a series DC wound motor, and I paired the motor controller with this motor because they both have the same voltage ranges and the same power ratings. This is designed to run optimally at 72 volts and 144 volts. I'm only giving it 46 volts right now, but I will still get a good throttle response. But before I put it in a vehicle, I plan to run the system at around 130 volts, and that'll give the power that I need to propel a vehicle. Back to the controller here. I have the microcontroller circuit rebuilt on this breadboard because it's supposed to be right here, but I made some soldering mistakes and I'm going to have to rebuild this PCB before I put it in a vehicle. Again, I rebuilt it on this breadboard, and I'm using jumper wires to drive the pins that I need to in order to send the PWM signal to the MOSFETs here. Okay, I'm just going to vary the throttle and control the speed of the motor. So give it a little bit of throttle. Upon initial acceleration, I'm pulling about, the amperage jumps to about 50 amps and then settles to about 27 amps just with no load. And I'm not going to give it full throttle or the whole table will shake. But at 46 volts, I have a pretty good throttle response. So the motivation for this project is so that I can put this system of components and implement it in an electric vehicle conversion. And the motivation is actually right here in the garage with me. The goal is to convert this 1981 VW Rabbit truck to electric. Right now it has a diesel motor in it, which puts out 56 foot-pounds of torque and 52 horsepower. And with my motor, I'm going to triple the torque and double the horsepower. So this car should be pretty fun to drive afterwards. So the overall cost I have in this project so far is around $850. Breakdown of those costs are the motor I bought for $350 used on Craigslist, and this was previously used in another EV conversion, and it powered a Chevy S10 pickup. The motor controller is an open source design that I found on the internet called the REV2C Cougar controller, and the cost of the components was $410. Those two components together, I saved a lot of money just by using used components and building the controller myself. These two components by themselves, brand new, easily $2,000 to $3,000 on average each. So $4,000 to $6,000 just in these two components. I've saved thousands of dollars just by getting a used motor and building the controller myself. The battery module, just these 3 modules is not going to get me very far, so I'm going to have to buy. I plan on buying 90 more of those modules. I really like that setup using the 18650 battery cells. They're a great cell to use for these conversions, and they're configurable, so I can put them in the car and situate them how I want to very easily. And they give me a ton of power, and they're just a great battery to use for conversions. So I plan on buying 90 more of those cells for a total pack voltage of around 130 volts, and that'll be around 12 kilowatt hours, a 12 kilowatt hour pack, which will get me about 30 miles down the road, which is a good starting point for me. So when I get the rest of the battery packs in, that'll bring me to about $1,800 for the main drive system components. I bought the vehicle for $700, so that brings me to around $2,500. There are a lot more components that need to go in an electric vehicle conversion. This is just an overview of the main components, the drive system. My hope is to keep the budget of the EV conversion under $5,000, and I think I'm at a pretty good point right now to achieve that goal. So this is my project. Thank you for watching.